Good morning to all. This is Vengala Narendra, Assistant Professor of Mathematics. Discuss the continuity of f of z is equal z by mod z z not equal to 0, z by mod z not equal 0 at z is equal to 0. Now we have to check at the origin. Check at the origin. Now here, now whether it is continuous or not, we have to check that one. Now here solution. Now continuity means limit function is equal to function value. Now function value at f of 0 is equal to 0 at z is equal to 0, that is 0, that is given in the problem. We need to identify the limit function. Now here limit z tends to 0 at z tends to 0. Now what is the given problem? Z by mod z. Now here to understand here limit z tends to 0, z is nothing but x plus iy, that is x tends to 0, y tends to 0, x plus iy divided by mod z, you know that under square root of x square plus y square. Mod z, you know that under square root of x square plus y square. Okay, now here we need to identify the limit in different paths, whether you get the same value or not. Now path 1 I am taking. Path 1. Now first along y tends to 0, then x tends to 0, then x tends to 0. Now what happens we see. Okay, first along y tends to 0, then x tends to 0. Now given problem I am taking limit z tends to 0, z by mod z. Now y tends to 0, x tends to 0, x plus iy by under square root of x square plus y square. X square plus y. First apply y. Now this equals limit x tends to 0. I am applying y. Wherever y is there, you put 0. X plus I into 0 divided by under square root of x square plus 0 square. Limit x tends to 0, x by x. Now square root get cancelled. This is 0. This square root get cancelled. X by x, that x cancel 1. Now limit x tends to 0, 1 is equal to 1 you get. In this path I get the limit value is 1. Limit value equal to 1. Next path 2, if I need to identify the path 2. Now path 2, first along x axis. Instead of y first, I would like to take first x axis. First along x tends to 0, then y tends to 0. First along x tends to 0, then y tends to 0. Now here, now in this case, what is the value of limit we need to calculate? Now limit z tends to 0, z by mod z is equal to limit, first you take x along x, next you take y. Now what is the function here? X plus iy divided by under square root of x square plus y square. First limit x limit apply. Limit y tends to 0, 0 plus iy divided by under square root of 0 square plus y square. Limit y tends to 0, iy by square root y square. Now get cancelled. Limit y tends to 0, iy by y. y cancel, you get I. Observe here. Then along the path 1, that means first if you apply y, next x, I get 1 value, limit value 1. Along the path 2, first that means I have applied here first x, next y. First x, next y, next I get the I value. That means the limit value Okay, here limit exists but not equal. Limit exists but not equal. Limit is not equal. Different paths have different limit value. Therefore, what you say, the limit does not exist means the given function is not continuous. Okay, if the limit does not exist, you can say if the function value not exist, if the limit value, function value both are not equal, in these all cases you can say the function is not continuous. Here a limit is not equal. The limit is not equal, therefore you can say the function is not continuous. Limit is okay. Path 1, along the path 1 and path 2 both are different. Limit does not exist at the origin. Limit does not exist at origin. Limit does not exist at origin. Limit does not exist origin. Limit does not exist at origin. Therefore fz is not continuous at origin. Not continuous at origin. Okay, if then you can say here by this problem you can understand when the function is continuous. When okay, in all paths when you get the same limit or not, then only limit exists. Okay, if it is exists, we see some more different examples to understand the complete concept. Okay, this is continuity. Next to differentiability. On the differentiability we see how the analytic functions. Here we consider the analytic function. Okay, when you say analytic, when you say not analytic, by some more examples we understand here. Thank you.